Hi, today we are looking at annuities and investments and loans. So essentially, we will be looking at things where we are either regularly investing money or regularly paying money off or taking money out of something. So we have two main formulas for this, which we'll be going into it. So an annuity is defined as a series of deposits or payments made at equal time intervals. So this covers investments as well as paying off loans such as mortgages or car payments. Now, our first one is amount of an annuity. This is also referred to as our future value formula. So this would be our equation for if we're investing and saving money. Now, A is the amount we end up with. R is how much we are regularly investing in. So usually it's monthly, so we'd have a monthly amount we're putting in. And then we have 1 plus I, which is our interest rate per compounding period. So we don't just convert to a decimal, but we also have to divide that decimal by how many compounding periods per year. N is the number of deposits or payments total. So if, for example, it was compounded monthly for 2 years, our N would be 24 because we'd be doing 12 a year and then multiply that by number of years of 2. So that'd give us 24. And then our I here is our interest rate per compounding period. Okay, so we have this example, a regular deposit of $200 was invested in a savings account at the end of each month. The interest rate is 3% compounded monthly. What is the amount of annuity at the end of 30 years? So what we need to do is write out the information we have. So we have our regular payments of $200. Now we have an interest rate of 3%. So our 3% as a decimal would be 0.03. However, it's compounded monthly, so we're going to have to divide that by 12. So that gives us 0.0025. And our N is how many payments total. So we are making 12 payments a year for 30 years. So our N is 360. Okay, so writing out our equation, we have R times 1 plus I to the N minus 1 over I. So we'll fill in our information. So we have our amount is equal to 200 times 1 plus 0.0025 to a power of 360 minus 1, all divided by 0.0025. So we'll follow BEDMAS as we do this. So we've got 200 times 1.0025 to a power of 360 minus 1 divided by 0.0025. Next, we'll do this exponent. So we've got A is equal to 200 times 1.0025 to power of 360 is 2.4568. We've got minus 1, so we need to do that next. That's over 0.025. So we have A is equal to 200 times 1.4568 over 0.0025. We'll multiply the values in our numerator together. So that gives us 291.368 divided by 0.0025. So that tells us at that point we should have an amount of $116,547.38. Now, if we had just looked at how much we would have if we did not have our interest acting, what we could do is take our total payments of 360 multiplied by 200, and you can see that we invested 72,000. So we invested 72,000, ended up with $116,547.38. Next example, suppose you want to save for a down payment of 50,000 to buy a home in 12 years. You invest in a stock portfolio that pays 4.8% interest compounded monthly. What should your monthly deposit be? Okay, so we want a value of 50,000. We want to buy a home in 12 years, or N. It's compounded monthly, so 12 times 12, so 144. Our rate is 4.8%, which is 0.048 divided by 12. So that gives us 0.004. And we need to figure out R. So we have our equation. A is equal to R times 1 plus I to the n minus 1 over I. Oh, sorry. It's not R, it's I. Just mix that up with other equations. Okay, so we have our A value is 50,000. That is equal to R times 1 plus 0.004 to a power of 144 minus 1 over 0.004. So we'll multiply both sides by 0.004. So we've got 200 is equal to R times 1.004, because I'm adding those together, to a power of 144 minus 1. So we'll do our exponent next. So we've got 200 is equal to R times 1.77686 minus 1. So we've got 200 is equal to R times 0.776866. We will divide both sides by this, so divide by 0.776866. Now calculating this gives us $257.44 as our R value. Okay, so that's our equation for if we're investing money. We also have the present value annuity. which is PV is equal to R times 1 minus 1 plus I to negative N over I, where PV is our present value. So this is if we owe money or are taking money that we've saved and pulling money out of it, and then the value is going to 0. So for example, a person buys a washing machine and dryer. He pays $100 a month for 2 years, an annual interest rate of 2.4% compounded monthly. What is our present value of the loan? So reading through this, we've got an R of 100. We have a time of 2 years. It's compounded monthly, so that means our N would be 2 times 12, so that's 24. Our interest rate would be 0.024 divided by 12. So that gives us 0.002. And then we'll fill out our formula. So we've got PV is equal to R times 1 minus 1 plus I to the negative N over I. So we've got PV is equal to 100 times 1 minus 1 plus 0.002 to a power of negative 24. All divided by 0.002. So we'll follow bed mass and solve this. So we've got PV is equal to 100 times 1 minus 1.002 to a power of negative 24 over 0.002. So we've got PV is equal to 100 times 1 minus 1.002 to a power of negative 24 gives us 0.953. We're dividing that by 0.002 eventually. We'll do the subtraction. So we've got PV equals 100 times 1 minus that last answer. Gives us 0.468. Divide by 0.002. We'll multiply these together. So we've got PV is equal to 100 times 0.468 is 4.68. Divide by 0.002. And that gives us a present value of $2,341.03. So this is how much they owed. Essentially, if we want to do how much they paid, we would just take our N value of 24, multiply it by their payments of 100, and see that they paid 2,400. So they ended up paying, and that's just roughly $60 in interest. Okay, so for this example, we have a person has saved $500,000 for retirement. Investment earns 3.6% interest compounded quarterly. At age 65, how much can be withdrawn quarterly to have enough money until age 95? So if they currently have 500,000, so that's our amount we're starting with that we're withdrawing money from. We've got an interest of 3.6%. It's compounded quarterly, so we'll change it into decimal. And then because it's 0.036 and quarterly, we're dividing by 4. So that gives us 0.009. Now, our N, it's quarterly, so 4 times a year. And then for 30 years, so our N is 120. So we'll write out our formula now. So we've got PV is equal to R times 1 minus 1 plus I to the negative N over I. So we've got 500,000 is equal to R times 1 minus 1 plus 0.009 to a power of negative 144. And that's being divided by 0.009. So first thing I would do is multiply both sides by 0.009 to get rid of this fraction. So that gives us 4,500 is equal to R times 1 minus 1.009 to negative 144. We'll do our exponent, and that's, so we've got 4,500 is equal to R times 1 minus 1.009 to the power of negative 144 is 0.27515. We'll do the subtraction. That's, we have 4,500 is equal to R times 0.7248. So we'll divide both sides by 0.7248. So 4,500 divided by 0.7248 gives us $6,208.74.